In chemistry, one of the most important types of concentration is called molarity. Molarity is using the number of moles, and just recall, a mole is 6.02 times 10 to the 23rd of something. It never defines what that something is, but we say we have a mole of atoms, then it would be a mole of atoms. And recall that we can convert from mass to moles using molar mass. Now we're going to look to see what kinds of calculations we can do with molarity. To start off with, we need to know what molarity is, and molarity is defined as the number of moles of solute per liter of solution. As we've seen previously, in general, our concentrations are going to be solute on top, solution on the bottom, and that's going to be true for all of the ones that we do calculations for. Solute on top, solution on the bottom. We may be able to flip this over because this is a ratio similar to the way that the percents were ratios, so you never know which one goes on top or the bottom. But when we write it out, molarity is defined as the moles of solute per liter of solution. And do notice that the units on this are liter, not milliliter. We saw in the percents that we had milliliters. In the molarity, it is liter. There are several ways to ask for molarity. You may see a question that says, what is the molarity of a solution? Or you may see something that says, what is the molar concentration of a solute? We also have several ways of expressing it, the units. So sometimes it's just a capital M. Other times you'll see it with a capital M with an underscore. And then sometimes it's abbreviated MOL/liter or mole per liter. So you see lots of different ways of doing it. But again, all of these are ways of saying molarity, and that is moles of solute per liter of solution. And the final way of writing it is a little bit unusual. In this case, what we're going to do is we're going to write a square bracket, and inside of it will be the chemical that we're identifying to find its molarity or molar concentration. And then we'll put an equal sign, and then we'll write the number that is that concentration. This is used especially for acids, bases, and batteries. So if I want to know what the concentration of an acid is, I'll put a bracket, put the H plus inside, and then that will tell us the molar concentration. So when is molar concentration used? Well, it is most commonly used when I have just one solvent and one solute. It is also commonly used for us to convert from one chemical to a different chemical because we can see how they react with each other or how much product is produced. So molarity is used for a lot of chemical calculations. Before we do the calculations, let's talk a little bit about some reminders about molarity. So first off, the units are moles per liter, and it is always solute over solution to find the molarity. There are going to be two types of problems. They're going to be the find the molarity and the use the molarity. And again, very similar to what we did with the percents. If it shows a molarity, then that must be a use the molarity. If it says what is the molarity, obviously that's a find the molarity. So those are our two types of calculations, and we'll see that on the next few pages. One of the biggest problems with molar calculations is that we are looking for moles, and yet in the laboratory we can't measure a mole per se, but we can weigh a mass. So if we know how many grams we have and we divide that by liters, that doesn't get us our molarity. But if we change it from grams to moles, then we will have the molarity. And how we get from grams to moles is that we're going to be using the molar mass. Remember, molar mass is how many grams of a substance there are in a mole of that substance. The second thing to remind you about is that very often we measure things in milliliters rather than liters, so you will need to know how to convert from milliliter to liter. So just to remind you, you go from where the decimal currently is, and you're going to go back 1, 2, 3 spaces to find out the volume in liters rather than milliliters. Similar to the percent calculations, the first step of this process is to decide what type of problem you have. And in this case, it says, what is the molar concentration? And so that should give you the clue that this is a molarity question. For the molar concentration calculations, we know that we're going to have solute on top and solution on the bottom. And in this case, because we know that it is a molar concentration, we know that we're going to have moles on top and liters on the bottom. The second step is to decide if it's a find it or a use it. And again, we look at that first sentence and it says, what is the molar concentration? So clearly we don't know the molar concentration, so this is a find the molar concentration, a find it problem. The next step then is to find out what is your solute, solvent, and solution, and what do you have present. So we're going to go ahead and read through the question. It says, what is the molar concentration of a solution which contains 15 grams of NaOH, sodium hydroxide, with a molar mass of 40 grams per mole that is dissolved in enough water to make 200 milliliters of solution. So let's start reading all the parts. We have 15 grams of sodium hydroxide. That is the mass of our solute. Next we have a molar mass, and that doesn't say it, but it is the molar mass of sodium hydroxide. And then it says dissolved in enough water. That's our solvent to make 200 milliliters of solution. So right now our answer is in solution. In this case, we don't know how much water is present, our solvent, but it doesn't matter because we don't need that for the calculation. The first thing I'm going to do while analyzing this problem is to actually take the 200 milliliters and turn it into the correct number of liters of solution. So we're going to go back 3. So it goes from 200, we go back 1, 2, 3, and we get 0.2 liters of solution. That helps to have everything organized in the right form first. And then we're going to kind of write it as we see it. So what's happening in this process is that you're taking the 15 grams of your solute, NaOH, and you're dissolving it in 0.2 milliliters of solution. So we're going to put that on the bottom. So right now we have grams of solute over liters of solution. Pretty close. We got the liters where we want it to be, but we actually want it to be in moles, not grams. So now I want you to look at it and see if I have grams on top in my molar mass, what goes on the bottom, grams or moles. Hopefully you see that grams goes on the bottom, and that 40 stays with the grams, so we're going to put 40 grams on the bottom and 1 mole on top. We now have our answer in moles per liter, which is exactly the units we're looking for. Now we just have to put it into our calculator, and in this case, we're going to take our 15 divided by 0.2, and then divide that by 40, and you will find that you end up with 1.875 moles of NaOH per liter of solution, or 1.875 molar NaOH solution. And again, because of the way that our program is written, we're going to write it as 2 decimal places, and that answer would be 1.9 molar. Some people like to memorize patterns. If you're one of those people, you'll find, in this case, that the molarity, big capital M, is equal to the mass of the solute divided by the volume of the solution divided by the molar mass of the solute. And again, we're going to start these problems by reading through them and finding out if it's a percent problem or a molarity problem. And right away we should see that it is a molarity problem. We see this capital M. We do not see a percent sign or the word percent anywhere. So this is a molarity problem. And again, molarity is defined as moles of solute per liter of solution. So we're going to start with that. Now let's decide if it's a find it or a use it. And in this case, we are given the molarity, so this must be a use the molarity question. We're not looking for it. We already have it. And now let's read through the question and see if we can find our solute, solvent, and solution, and what information we can find about our solution. So just reading through the question, we see how many grams of sodium acetate with a molar mass of 82 grams per mole are required to prepare 8 liters of a 0.250 molar sodium acetate solution. The first thing we know is that we're going to be looking for the grams of sodium acetate, which is our solute. We know the molar mass of sodium acetate, and that's 82 grams. And we're going to write that over moles so that we can see that that is a ratio. Next, we're going to see that we have 8 liters of solution. You have to read all the way across. And finally, we know that we have a molarity of 0.250. That's moles of sodium acetate per liter of solution. So we can see that that is also a ratio and not a good place to start the question. So we have 3 numbers to work with. We have 82 grams per mole, 8 liters of solution, and 0.250 moles per liter. And so we would need to figure out how to get these to work out right. Now you can choose where to start. I prefer to start with one that is not a ratio because we know that that is an exact number that we have to work with. So we're going to start with the 8 liters. And then looking at our two choices, which one has liters that will cancel out with that liters and turn it into something else. In this case, we're going to go from liters to moles. And that means that we're going to use that 0.250 moles per liter. Notice that the liters of solution cancels out, and leaving us with our answer now in moles of solute. But we're not looking for moles of sodium acetate, we're looking for grams of sodium acetate. So we need to do one additional step, and that is to multiply that by the molar mass. In this case, we see that there are 82 grams for every 1 mole of sodium acetate. So those two cancel out, the moles cancel out, leaving our answer now in grams of sodium acetate. And again, if you prefer to memorize and follow patterns, you will see that the mass of the sodium acetate is going to be equal to the molarity of the sodium acetate times the volume times the molar mass. Now let's put that in our calculator, and we're going to have 8.0 times 0.250 times 82, which gives us 164 grams of sodium acetate. And finally, for the online homework, exams, and quizzes, you'll want to write in 2 decimal places as the directions tell you at the top, and so you would write 164.00 for this answer.